Good afternoon, everyone. Welcome to our Recitation 10. And in this class, we will finish the worksheet 10. But before that, let's cover the remaining part of the unit test 2. I believe currently you should be able to check your grade. I have already finished all the grading and the curving. Actually, this morning I just finished all the curving for the test. And here I would like to share the screen with you. Actually, for your sections, your average score is a little bit higher than this one. So you did a good job this time. Although the class average is lower than the previous one, I think one of the reasons may be because the test 2 happens after the spring break. And maybe after the spring break, some students feel a little bit, lost after that 1 week of the break. But I think the test 3 will be better. But if you have a concern with the result of unit test 2, or if you are very worried about the final grade, you are welcome to contact me in email, and I can tell you what you did wrong in this test. I can also give you some suggestions for the future learning. So let's start to talk about the remaining parts in this test. In the last recitation, we have covered all the multi-choice. And in this one, we will talk about question 9 to question 13. Question 9 is talking about this type of thing. One person was pushing a box on a rough surface. After he released it, the box will keep moving for a while until it stops. And then the question 9 contains 3 small questions. The first one is, what is the final kinetic energy after the box stopped? And for this part, almost all of the students in this section have provided me a correct answer. So after the box stops, the kinetic energy will drop to 0, right? And can you explain which force has consumed the kinetic energy? Actually, after this person released the box, the only force on the horizontal direction is friction force. And the friction force is always doing the negative work and consume all the initial kinetic energy. And for this part, most of you have answered correctly. Any question? And but for the final one, we got some error here. What form of energy has it turned to? So some students mentioned potential energy. However, the friction force is a conservative force, which cannot provide or related to a potential energy. Because this energy, friction force, is doing the work, negative work, is strongly depending on the path it has passed. And the energy it consumed cannot be stored there. And you can say it has turned to the heat energy or thermal energy or internal energy. All those answers, I have granted you the full credit. However, if you're talking about potential energy, you will get a little bit deduction here because you answered this question wrong. Okay? And especially some students mention gravitationally potential energy. Gravitationally potential energy equals to mgy before we learn the universal gravitationally potential energy, right? So it's only depending on the height of that, on the vertical position of your object. But this box is keeping moving horizontally. So the gravitational potential energy actually didn't change. It finally will change to, most of them will change to the heat energy. So after you learn the physics 3, will learn that it's not only transfer to the heat energy, partially it will also transfer to other type of energy. However, if you mention the heat energy or thermal energy, you have been doing a very good job in physics 1, and you have gained the full credit here. All right? Any question? If you have no question, we will move to question 10. Okay. For the question 10, I will open a blank document to explain that. We have talked the same thing in the short video, so I noticed some students answer that with the correct answer provided in the short video. That's very good, and of course you will get the full credit. So in the short video, I explained the airbag, the effect of the airbag by this way. I explain that by impulse. I equals to the change of the momentum. And in the collision, the change of momentum cannot be avoided because initially you got a velocity, and after the collision, the driver and the car, all of them will reach zero velocity. So the change of the momentum cannot be avoided. So what can we change to decrease the impact? So the impulse can also be calculated as force times the time it has experienced. And if we can extend the time it has experienced, since delta P has no change, force will got decreasing. And this is one way to explain that, and that's a very perfect answer. However, some students want to explain that with other series of law. It may be correct due to the reasoning you have provided. So I graded that according to the reasoning, not limited to the only answer here. So another possible answer is here. You can explain the same situation with Newton's second law. It's possible for us to do that. Force equals mass times acceleration. And acceleration is defined by the change of the velocity over t. And if you can extend the time it has experienced, and then you can change the acceleration and decrease acceleration, and then decrease the force. So that's another good reasoning to answer this question. Okay. But if you mention some laws but didn't explain that correctly, how it can impact the force, you cannot get the full credit. And by the way, I also see a very good answer is here. So some students answered this question by the change of the displacement, because the airbag, it extends the displacement it has changed, because it has a deformation for this airbag. So the displacement for the driver and passenger will be extended. That's also possible to explain that from kinematics derived conclusion. If you increase D, you decrease A, and then decrease F. That's another way to explain that. Okay? So any question for question 10? Okay, if you have no question, we will go to the calculations. I want to explain the difficulty of the three calculations. For the question 11, I increased the difficulty of our homework question. So that's why this one will be the most difficult one, I think. And I lower the deduction. Even you provide a wrong answer, I didn't deduct too much. I mean, I didn't deduct the full credit here, okay, because I think this is the most difficult one. And the second question is the question exactly the same as our homework question. And if I can figure out why you get it wrong, I will give you partial credit. But for many answers, I cannot get it why you get it wrong. Okay, if you have finished this question in your homework, it should be very convenient for you to get the answer. But if you forget about the question in your homework, it will consume some time to finish it, because it do need time to figure out the equations. And don't worry about the system correctness, because of course that's wrong. Our system cannot calculate anything about cosine minus 1. So I did the calculation and manually graded it. And for the question 13, ignore the answers here. The correctness of the system here. I just want to explain this one. The difficulty has been lowered from our homework. The homework question has a two-dimensional collision, and you have to calculate both x direction and y direction, and it will cost a lot of time. So consider the limited time in this test. I simplify that to a one-dimensional collision, and you only need to apply one equation, then you can get the answer here. And this question, is very similar with one question we have discussed in one of our recitations, right? Just before the exam. Okay, so here I will give the equations for 3 questions. You can ask me at any time if you feel confused. So for the question 11, to solve this one, I have already provided a hint. You need to draw a free body diagram. But the question is that in this system, there's not only one mass here, there are 2 mass. So which free body diagram we should draw? Okay, firstly, I will draw the scenario we are discussing. A box is dragged by a car, and the car has a mass m1. The box has a mass m2. So here are 3 possibilities for you to choose a system to observe and draw the free body diagram. The first one is that you can consider m1 and m2 as one system. Yeah, it's possible for you to do that, right? You can consider both of them in one system and do the free body diagram. And in that case, you will try to analyze that by it do receive a gravity force, a normal force. Normal force will equal to the gravity force, and a force provided by the engine and a friction force. And this friction force equals to mu k 0.2 times the total normal force. So after we analyze this system, we can solve what is a normal force very easily, which equals to m1 plus m2 times g. And we can also calculate what is a friction force. And we can also calculate what is engine force, because engine force minus Fk equals to, it will provide the net force equals to m1 plus m2 times acceleration. So then you can calculate the engine force. So if the question is asking you about the engine force, this type of the analysis will give you the quickest way to solve the problem, to solve the engine force. However, this question is not asking you about the engine force. Instead, it's asking you about the force exerted by the car on the box. And that is the internal force if you are considering the 2 mass as one system. And if we are considering the internal force, consider them as one system cannot helpful for us to get the final answer. We have to analyze that one by one. We have to analyze that one by one. And here, there are 2 choices again. You can choose M1 as the object you are analyzing. You can also choose M2 as the object you are analyzing. So to give you a full picture about this question, I will draw the free body diagram for both of them. Although actually for this question, the simplest way is to draw the free body diagram for the M2, and that's enough. But just as I have said, I want to give you the full picture of this one. So if I draw a free body diagram for the M2, it receives a tension force exerted by M1 on M2. And it also receives a friction force, Fk2. It got a m2g gravity force and a normal force which equals to m2g. And that's why for this m2, if you are only looking at the m2, right now please just looking at the m2, you will get tension force minus Fk2 equals to m2 times a, and then the tension force will equals to Fk2 plus m2a equals to mu k is 0.2, n2, which is m2g plus m2 times a. And since we already know what is m2, what is g, 9.8, what is acceleration, and what, we don't need anything more. We can already solve what is the tension force provided by m1 on m2. And we can already solve this problem. And if you fortunately, at the beginning, you have already chose this one to analyze, you will get the answer very quickly. But maybe you didn't choose that to analyze. Instead, you are picking M1 to analyze. What will happen? If you pick M1 to analyzing, you still can draw the free body diagram, FK1, and the tension force, and then F engine. This is what happened in the car, to the car, right? So if you are picking M1 to analyze, you still can calculate the tension force, but it will be more complicated because if you choose M1 to analyze, you will see engine force minus T minus FK1 will equals to M1 times A. You have to solve the F engine firstly by this diagram, to solve what is F engine, and then you can solve tension force. So it will become more complicated for you to reach the final solution. And if you are choosing F2 to observe and analyze, you will very quickly get the correct answer. So this is a very tricky thing for this one. So why we have to choose M2 to analyze? So firstly, if you are not sure to choose which one to analyze, it's better for you to draw all the free body diagram for both of them. And then compare them, compare the free body diagram. Which one can quickly help you to get the answer? You will find that, okay, the left one will be quicker because we have already know all other forces here. And that's why we can solve tension force easily, right? And if you compare that, you will choose the left diagram to analyze, all right? And a question for this one. This is the most difficult one here. The most error happens. For example, some students calculate this force, and some students calculate the friction force. And some students use the friction force minus M2G, M2G, 2A minus the friction force. And that's another possibility for the error. Any question? For question 11, so everyone here has already obtained the correct solution, right? Do you still feel confused? If no, we will move to the next one. Okay, for the next one, I will cover that quickly because you can find the correct solution in your homework. So we solve that by this way. Work equals to Fx times delta Rx plus Fy times delta Ry. And it can also be calculated by the force magnitude times the displacement magnitude times cosine theta. And that's why cosine theta will equals to Fx times delta Rx plus Fy times delta Ry over the magnitude of the x times the magnitude of the displacement. Yeah, the calculation may be a little bit complicated, but you should be able to solve what is the correct angle. So for this one, a lot of students will get a minus number for cosine theta, and then you will get a theta which is larger than 90 degrees. Your calculator should be able to provide you the correct answer. And for some students who get a very low angle, for example, 20 something, 40 something, I cannot figure out why you get that answer. And if you have an explanation, and if you would like to provide more details for you to calculating the correct answer, I would like to add a little bit score for this question, okay? So any more question about question 12? We almost get half of the correctness here, okay? And for the question 13, okay, I know what's the why some students get the wrong answer here, because one student in other section has explained to me. Okay, but I cannot figure out all the errors why it happened. Okay, so I solved this question by the equation here. is a collision. So the momentum is still conserved here. Actually, this is a perfect elastic collision, but even you don't know if that's an elastic collision, that's still possible for you to calculate that. M1 equals to, the red ball, I said that's M1, okay, it equals to 0.8. The velocity for this one is to the right, 0.2 meter per second. And M2 is the blue ball, which is 0.6. And to the left, which equals to 0.5, but it's to the left, so I have to include a negative sign here. And the same thing will happen to the M1F. And V2F will get positive 0.3 meter per second. And 0.3 meter per second will go to this blank. And positive means it's to the right. So here you will answer to the right. I noticed some students trying to answer this question by 0.233 meter per second. I think you get that answer wrong because you didn't include the negative sign in your calculation. Okay, and for that kind of error, you will still get partial credit. And most of you have answered the correct direction here. So for this part, you will get some credit, even you put a wrong answer here. Okay. Any more question? Do you think this test is difficult? Anyone has a suggestion for this test? No suggestion? And anyone is worried about the final grade? I mean, if you don't want to talk it here, you can also talk it personally later by email, okay? If you have a concern about your final grade. And recently, I will check your homework result. And if some students didn't finish the homework for too many times, you will get a reminder email. I mean, the homework on the website. Okay, I will check that, the completeness here. All right, so we have finished all the talking for the unit test 2. Oh, I forgot to mention another thing. Okay, this one. So we also finished the conceptual quiz 8 in the last week. And I want to talk one of the questions, question 4. I have already got some question about here. So I think I'd better explain that before we move to the recitation class, recitation worksheet. So for this question, most errors happens when some students picked the location A, and currently I have understand why it happened, why you pick location A. So since it's like this one, in the last week we have discussed what is the universal gravitational force. So in the past it equals to mg, but in the last week you learned this equation. And after that, we also adjust the equation for the potential gravitational, gravitational potential energy, which is different from mgy. It equals to minus g times m over r. So when rf is larger than ri, we can get the magnitude. It looks like, the value or the absolute value for this one will be smaller. However, if you include a negative sign in your final answer, so the negative sign will change the comparison result, and then the location B will get a higher potential energy. That's the reason. However, it will make some students feel confusing because in the past, we often ignored the negative sign when we compare two quantities. The reason is that in the past, we compared the quantities, which is a vector quantity. For example, I have two velocity. I have two forces. One force is applied to the right, and I say it's 6 Newton. And another force is applied to the left. I say it's 8 Newton because it's to the left. I say it's minus 8 Newton. And if I asking you to compare the force, actually we only need to compare the absolute value of the forces. And that's why the F1 will be smaller than F2, the absolute value for the vector quantity, which has the direction. And the negative sign for the vector quantity means the direction. It means the direction, not means the value. It means the direction for the vector quantity. However, if we go to the scalar quantity, we have to include the negative sign, which is also actually included in your value comparison. So here is an analogy for this type of thing. So for example, if you are still using the old potential energy in your comparison, and here I define a 0 meter on the top of the water. And if some person who jump from 0 meter to the water, and then he or she reach the minus 1 meter, then this person will gain a potential energy, but it's a negative potential energy, right? So for example, at this location is 0. And finally, it will get a location, and I will say this person is 75 kilogram, and finally he or she will get around minus 735 joule. Okay, this is the final potential energy. And can you say the potential energy at this location is higher than the previous one? It's impossible, right? Get lower, the potential energy will get also lower. And that's why this person, when he or she reach the underground, he or she will get a lower potential energy compared to the higher position, right? So this example can be an analogy for you to understand what's happening to a gravitationally potential energy in a universal gravity force. So here it looks like the location B is higher than location A. You can also try to understand this question in this way. It's higher, and that's why potential energy at the location B will get higher. Okay. Any more question? If you have no more question, we will move to this one. We have already actually listed important concepts in the last recitation, but since today we will use that again. So I want to put it here. So in the chapter 11, we are actually learning what is the rotationally kinetic energy and what is angular momentum. And all of them are about conservation law. This kinetic energy has the same format as half mv squared. We just exchange the mass by the moment of inertia and velocity by the angular velocity. And in the short videos, I have used an example to compare the difference of the two energy. So the example is about the rolling. If you have an object which can be rolling, that means it do have a rotation as well as a translational motion. So two motions are involved here. And that's why if we have the rolling object, and if you want to calculate the kinetic energy here, you must include the kinetic energy from the rotational motion, which is half I times omega squared, plus the kinetic energy obtained from the translational motion, which equals half mv squared. And after we talk about kinetic energy, we also talk about what is angular momentum. I always trying to explain the definition for the new concepts in the short videos and explain why we get those kind of thing and what type of the equation can be derived for the angular momentum. But in the recitation class, I would like to focus on the application about those new concepts. So here, I will just give you the result we have derived in the short videos. Firstly, the definition. Torque is the change rate of the angular momentum, which can tell us angular momentum equals to R cross linear momentum. And it will also give us a derivation L equals to I times omega. In your problem solving, sometimes, of course, if you know all the information required for the definition equation, that's good enough for you to use this equation. However, in your problem solving, sometimes you didn't know what is the P, and in that case, maybe using this derived conclusion will benefit your calculation. So here I would like to give the highlight of the equation we are learning here. So you will use this equation and this equation for most of the time when you solve the angular momentum and rotational kinetic energy question. Okay, I will give you 1 minute to finish writing here. K total, yeah, K total. Okay, I need to thank you, make that. Oh, sorry. Have you finished the writing? If you have finished, we will go to our question 1. I will read this question together in the main room, and after that, you will be separated into 3 small groups and finish your calculation by yourself. Okay. So the question 1 is describing a rotational system. Initially, it only contains a uniform solid disk, which is rotating here. With the axis in the center. And for this uniform solid disk, it has already provided us what is the mass. So the mass is 2.500 kilogram. And it also provided us with a radius. R1 equals to 20.0 centimeter. And here with the beta, transfer this 20.0 centimeter into the SI unit, so that in the future calculation, it will be more convenient for you to use other SI unit. So here I transfer that to 0.200 meters, all right? And this solid disk, the moment of inertia has already been provided by this equation here. So you should be able to calculate what is the I1 here. The question also provides us with the angular speed. Angular speed omega 1 equals to 20.0 radian per second. Okay, so this is what has been provided in the question set. After a while, Eventually, you put a hollow cylinder on top of this disk, and the rotational system will become to this way. So currently, you got a very thin hollow cylinder here. And the solid disk is still there. So this is your new rotational system, and it must have a new angular speed. And what we know about this hollow cylinder, we know what is M2. We also know what is R2. Again, I will convert that to SI unit. And you should be able to calculate the moment of inertia. But here, pay attention, this is a hollow cylinder, not a disk. So you need to calculate the inertia of the hollow cylinder by this equation, not the left one, okay? And for the whole system, you can consider what is the total inertia here. How can we calculate the total inertia? I believe you can figure it out. And after that, you will compare the angular momentum, initial and final. They should equal to each other due to the angular momentum conservation. There's no external torque applied into the system. That's why the angular momentum is conserved. And you will get what is omega F by this law. After that, the question is also asking you to calculate the change in the rotational kinetic energy of the system. So the change of the kinetic energy will equals to the final kinetic energy minus the initial kinetic energy. And this number, we can estimate, even before the calculation, we can estimate this number should be minus. Because if you put that here and they gain the total, exactly the same angular moment, same angular speed, it's quite like an inelastic collision. And in that kind of change, the kinetic energy will get lost because nothing can increase the energy here, but it can decrease the energy here. Okay, so that's it for the question 1, and I hope you to finish all the remaining calculation by yourself, and you can discuss with your group member. You can also switch your group if you cannot, you want to discuss with other students. Okay. I will go to your groups after several minutes to check if you get the correct final answer. All right. Anyone has the answer for the change of kinetic energy? Okay, we can go to the main room and discuss there. And I mean, you can take more time for you to finish the calculation, okay? We will go to the main room, and if you still have any question about this worksheet, we can discuss there. All right, everyone, we have reached the end of this class. That's why I turned off the group mode. And until now, every group has already solved what is omega F. The correct answer is 15.4 radian per second. And if you have any concern about this part, you can ask it here. So anyone haven't get the answer for the omega F? All of you have got the answer? And if you have already know the answer about the omega f, it will be quite easy for you to finish the calculation for the second question. The change of the rotational kinetic energy equals to the final rotational kinetic energy minus the initial one. And the final one will equal to half times I total times omega f squared. And the initial one equals to half times I1 times omega 1 squared. So that is the equation for you to get the answer. You will get a minus 2.3 joule in this part. And you can take more time to finish your calculation, and I'm here to see if you need further help. All right? Yes, it's 2.3 joule, but you will get a negative 2.3 joule because that will be a decreasing for the kinetic energy, right? I think you didn't get the negative answer because you use the initial kinetic energy minus the final kinetic energy. So you just need to switch your calculation sequence. That's good. That's good enough. Okay. Yeah, make that you get the negative value. Very good. And Jamie, you just need to switch your calculation. For example, I guess you use 10 joule minus 7.7 joule. So that's why you get that one. But here we are using 7.7 minus 10. Okay, just need to switch the, yeah. Yes. That's fine. You can correct that quickly.